In critical manufacturing, a forged component does not begin at the press, and it does not end after forging. Its reliability is built across the entire forge-to-finish workflow: raw material selection, billet preparation, forging, heat treatment, machining, inspection, and documentation. The first stage is material pedigree. Before heating or deformation, the supplier must control grade, heat number, MTC linkage, stock segregation, and inward inspection. If material identity is unclear, every later operation carries risk. The second stage is billet preparation and forging. Heating is not simply about softening metal. Temperature control, preform design, deformation sequence, reduction ratio, and grain flow direction decide whether the component develops internal soundness and mechanical integrity. This is where forging becomes engineering, not just shaping. The third stage is heat treatment. Mechanical properties, toughness, hardness, stability, and stress relief depend on controlled cycles, furnace calibration, batch linkage, and verified results. Then rough machining prepares the component for precision without losing traceability. Inspection and NDT validate structural integrity. UT, MT, PT, dimensional checks, hardness testing, mechanical testing, and final machining all need linked records. Finally, the documentation dossier must connect every operation from raw material to dispatch. Forged to finish matters because it keeps accountability inside one system. For critical industries, buyers do not only purchase a machined component, they purchase a controlled, inspected, traceable, and defensible manufacturing history. This is why critical buyers prefer suppliers that connect engineering, material control, special processes, machining, inspection, and documentation inside one accountable system. The stronger the control, the lower the qualification risk.